Hello again, everybody. Welcome to today's video lesson on the notes. We're going to talk about 12.3. The other day in 12.2, we talked about surface area. That's a lot of what we're going to talk about in chapter 12. That and volume. We hit prisms and cylinders in 12.2. Today in 12.3, we're going to talk about the surface area of two main shapes: pyramids and cones. Now, the main thing that makes a pyramid and a cone is that they only have one base, okay? Prisms and cylinders had two bases. Pyramids and cones only have one base, okay? Pyramids have triangular sides. We saw that prisms have rectangular sides in 12.2. Pyramids rather have sides that are triangles. And then the base is maybe a triangle or a square, or maybe even something like a pentagon or a hexagon possibly. But pyramids are named by the bases, shape of the base, but the sides are always triangles, okay? And then we know usually what a cone looks like. We should know what a cone looks like. Cone has a circular base, and then everything just comes together to a point called the vertex of the pyramid. Okay. Let's go ahead and look at the generic surface area formula. There is one for pyramids and cones. It is right here. And we'll talk about what everything means. Surface area for pyramids and cones. And we'll focus on pyramids a little bit first. Capital B, which again stands for area of the base, like it did in 12.2. So the area of that base goes in for capital B, plus, a little bit different now, 1/2 times P. Capital P is also, like it was in 12.2, the perimeter of the base, add up all the sides, perimeter of the base, times a lowercase cursive L. And this is the slant height, okay? So a cursive lowercase L in geometry in the formula stands for the slant height. And the slant height is exactly what it says. It is the height that is not straight up and down. It is slanted. It goes up and down the side of the figure, okay? So like if you have this cone right here, the normal height would be going up and down inside the cone from the center to the vertex here. But the slant height goes up and down the side of a pyramid or a cone, okay? Now, keep in mind, like I put over here, sometimes you're given the slant height, which is nice. Sometimes you're not. But you cannot use regular height of the shape for a pyramid or a cone. You have to use slant height. There's no regular H in this formula. Okay, except maybe if you're trying to find capital B separately. You cannot use the normal height. If they give you the normal height but not the slant height, you have to solve for the slant height. And the most common way to do that is to do, look at this guy, Pythagorean Theorem. So sometimes you might have to do Pythagorean Theorem first to get the slant height, because everything's going to form a right triangle for the most part. Check this out down here real quick. The normal height straightened up through the center. Well, in a cone or even a pyramid, you can have a radius or some other length halfway through the base. It makes a right angle. And now look at what you have. You have a right triangle built in here. And your slant height up and down. So if they give you the normal height, it makes a right triangle with this segment, in this case the radius, so you can use Pythagorean Theorem to get the slant height out. All right? So keep that in mind. All right? All right, so we're going to use this for pyramids and pretty much also for cones. Let's look at cones real quick. Cones, you can use the same formula. The only difference is that, remember, you really don't call it the perimeter of the circle, you call it the circumference. So you can adjust this a little bit to B plus 1/2 CL if you want. Just remember, perimeter of the cone is the circumference of the cone, which is the circumference of the circular base. Okay? And one last thing, the term lateral area. They're going to want you a lot in your homework to identify not only the total surface area, but also the lateral area, so make sure you do that. But you get the lateral area on the way to the surface area anyway. Remember, the lateral area means everything except the base. Just like in 12.2, you take off the two bases, and the rest of it, the pH part, was your lateral area, if you needed that. Well, in this generic formula that we're using today, you take off the base, and it's the 1/2 PL part. So this, in the formula today for pyramids and cones, gives you your lateral area. We'll call lateral area LA. Okay? For abbreviation. So lateral area, just take the base off, which is your capital B, and the 1/2 PL or 1/2 CL, that gives you your lateral area. Okay? Okay, let's go ahead and do the examples on the back and practice applying and using the formula. All right? Now, keep in mind that, like I just mentioned a few moments ago, some of your homework problems want you to also find the lateral area. So we'll just identify that as we're getting the surface area, okay? All right, here we go. Number one. We have a cone, 18 up and down the side. Here's your slant height, cursive L. Here's your diameter. Radius is going to be half of that, 15. R equals 15 if we need it. All right, let's bring up the formula. Surface area is capital B plus 1/2 PL or CL. All right, on the side, we're going to have to get capital B. Capital B is the area of the base, the circle. So that is pi r squared for a circle. So we square the radius 15 and multiply that by pi. 15 squared is 225. All right, so capital B is 225 pi. We'll keep it in terms of pi for now until we see what we have. 1/2 CL, we also need the circumference. We can calculate that on the side. Circumference is pi times diameter, remember. So diameter 30 times pi is just 30 pi. We can keep it like that for now. And then the slant height's going to be 18. 1/2 is a half. All right, so we're ready to plug everything in. So capital B, 225 pi. Plus 1/2 circumference C, 30 pi. Times L, the slant height, 18. All right, we can keep the pi here. And if we take half of 18 is 9 times 30 is 270. So this all becomes 270 pi. 225 pi, we're going to add to that. Now, if we stop for a second, remember we said that the 1/2 CL part was our lateral area. All right, so that is the 270 pi part. So if we're going to identify the lateral area, 270 pi. There we go. Now we add these to get the total surface area, and we come up with 495 pi. We can put a unit on our answer. Looks like centimeters. You can also put centimeters squared on your lateral area. And there we go. For number one, lateral area here, total surface area, the entire equation right here. All right, let's look at number 2. Number 2, we have a pyramid. All right, we're going to bring up the generic formula. Capital B plus 1/2 PL. All right, here we go. Let's start figuring out what capital B is. Capital B is the area of the base. We have a 12 by 12 square base. So that's easy. 12 times 12 for the area, 144. P is the perimeter of the base. Perimeter, 12, 12, 12, and 12. Add up the 4 sides. 4 sides of 12 gives us a perimeter of 48. So we have capital B value. We have capital P value to plug in. Slant height, let's look. Now, you're not going to use 10 for the slant height. That is your normal height going up and down the inside from top to bottom. Makes a right angle. So, like we mentioned on the front side, we're going to have to solve for the slant height. Pythagorean Theorem. You'll see we have a right triangle. Here's your actual slant height going up and down the side here. If we kind of draw it in. So you'll notice we have a right triangle. Now, all the way across is 12. This is halfway. So this is a side of 6. And this leg is 10. So we have legs of 10 and 6. We're going to pop those into the Pythagorean Theorem and solve for your slant height. So Pythagorean Theorem over here. 10 squared plus 6 squared for our legs. That's 100 plus 36. Or 136. Remember, take the square root. And that will give you your hypotenuse. That comes out to be about 11.6. All right, so we're ready to plug in. Capital B 144. Plus 1/2. Perimeter was 48 for P. And 11.6 for your slant height L. All right, we need to calculate this. Half of 48 is 24. If we multiply that by 11.6, we get 278.4. And we're going to add 144 to that to get our final surface area answer of 422.4. And our unit is what? Feet. So feet squared or square feet. Now that is our total surface area. Our lateral area, remember, is your 1/2 PL part, which we saw was this product, which is 278.4. So if you want to identify LA lateral area, 278.4. Guys, remember to get full credit on your homework. You got to follow all the directions. Book directions say to give the lateral area, give the surface area. So you don't have to write it separately. If you just want to circle it, identify lateral area, I got to see that. So make sure that you are identifying or giving what the lateral area is. You understand that, as well as the total surface area for those problems that tell you to do that. All right, moving right along. 1 and 2, we applied the formula to just simply get the surface area. Now we're going to look at using the formula for other types of problems. So number 3, it says the surface area of a cone is 96 pi, and the radius is 6, and wants us to find the slant height. All right, so we're going to have to use our formula and work backwards a little bit here, okay? Now, here is the generic formula. Surface area, we're dealing with a cone. So the cone is going to be capital B plus 1/2 CL. Now, look, we're solving for the slant height L. It gives us a surface area. We're going to have to figure out what B and C are because it tells us the radius. So then we can work backwards in the formula after everything's plugged in and solve for L. So on the side, let's get B and C. B is the area of the base, which is pi r squared. Well, r is 6. So it's pi times 6 squared. or 36 pi. And then capital C is pi d, pi times diameter for circumference. Well, if the radius of 6 diameter is 12, right? So 12 pi will be your circumference. All right, so now we have our surface area. We have our B and C values. We're ready to plug in and work backwards to get L. So here we go. 96 pi for surface area. Capital B is 36 pi. Plus 1/2 C is 12 pi. And we have L, which is L because that's what we're solving for. Okay, a couple different ways you can work through this problem to get L. One thing you can do 1/2 of 12, which is 6. So this is 6 pi L. One thing you can do if you want is, I don't know which way I want to go here. All right, I'll just go ahead and subtract 36 pi to get rid of that. So that is 60 pi on the left, and you still have 6 pi L on the right. Now you want to get L by itself, so divide both sides by 6 pi. Over here, you got L by itself, you're good to go. Pi's are going to cancel, and 60 over 6 is 10. So the slant height is 10. And there we go. And we don't have a unit, so just slant height. Now guys, we had a nice whole number 10 here. You don't always get a whole number. If you get a decimal for the slant height or whatever you're solving for, that's okay. That's number 3. Now, before we do number 4, the last problem, I've given you some hints on number 18, number 23 in your homework. Go ahead and look at that if you need to. Okay, follow that. Here's a hint for 18. And 23, you're going to do this and then work backwards like we did number 3. All right? All right, let's finish up with number 4. Now, number 4 says a cone has this radius of 4, this slant height of 12. It wants you to describe how a change in certain dimensions affect the surface area. So you got a cone, certain radius and slant height rather. Part A says that the radius and the slant height are tripled. Now, one way to do this is to actually find the surface area with these. And then for part A, actually triple these, multiply by 3 to get a new radius and slant height, and then refigure out the surface area, and then see how it changed. But I'm gonna show you how to do it a little bit differently to save you a little bit of work. All right. Now I'm gonna go ahead and bring up a separate piece of paper because I need more room than just this. Now we're talking about a cone and the surface area, so we're gonna make up the surface area of a cone. Surface area of a cone is capital B plus 1/2 CL. Now, if you look at the surface area, all right, it's talking about the radius changing. Well, we have our slant height L, but we don't have an R in here. We want to mess with this formula a little bit, manipulate it, change it around so that we have an R. So we can see what's going on with the radius and slant height. So capital B is the area of the base. That's pi r squared. Capital C is circumference of the circular base, which is pi times diameter, or 2 pi r. We'll use 2 pi r because that we're dealing with the radius here changing, and then L is just L. Now, here is a little bit of an adjusted formula for the surface area, okay? And then these kind of cancel, but they're really not, you're not going to need them here anyway. Now, part A says that the radius R and slant height L are tripled. Let's look at where R and L are in the formula. R is here, and the slant height L is here. Now, r squared is the same as r times r, right? So I'm just going to write it as r times r. Now, you got this part being added to this part. Now, both of these are tripled or multiplied by 3. So times 3 for this radius, times 3 for that radius, and times 3 for that radius. And L, slant height, also tripled, so times 3 for that slant height. Now notice how both of these are consistent. Times 3 times 3, same as times 3 times 3. That's good. Because what's 3 times 3? 9, right? So since both of these parts of the formula are both being multiplied by 9, the whole thing's being multiplied by 9. And that's going to be your answer for part A. Okay? So again, you had r squared, which is 3 squared or 9, because 3 times 3 times 3. And the second part, you had the r and the L, which is times 3 times 3, another times 9. So if you have a cone and you triple the radius and slant height, since both of these parts are times 9, the entire surface area goes up by 9. So 9 times more is the answer for part A. Okay? So you can see how you can do this a lot simpler than having to go through the whole formula with 4 and 12, timesing by 3 to get what? 12 and 36, and going through the whole formula again. All right, I kind of just showed you how it breaks down. All right, so let's see how we do part B kind of quickly after I showed you all this, which took forever. Here, we're dividing the radius and height by 4. So, remember, first part has r squared, or 2 of them, right? Well, so you have a 1 divided by 4, another divided by 4. Second part has an r and an L, both divided by 4. So you have another divided by 4, another divided by 4. Both of these are the same. And you want the total that you have. Well, if you divide something by 4 and divide by 4 again, you're dividing by what? 16, because 4 times 4 is 16. So this is the same as dividing by 16. And same thing here, divide by 16 in the second part. Both of these are the same. So if you only take a fourth of the radius and slant height, or divide the radius and slant height by 4, you are really dividing the surface area by 16. And that's how it changes for that. Okay? Now, some of y'all might be asking, well, what happens if you like triple the radius but quadruple the slant height, or divide the radius by 2 but divide the slant height by 8? Well, you do something similar to this, but it's a lot more complicated with the numbers. So we're keeping it simple for now. That's a whole nother ball of wax, or box of nails, or whatever, can of worms, or whatever you want to call it. All right, guys, there we go. 1 through 4 examples, a couple homework hints, and that's today's lesson. Y'all have a good rest of your week, and talk to you later. Bye-bye.